Okay, cool. 1203, sort items by groups respecting dependencies. There are n items, each belonging to 0 or 1 of m groups, where group sub I is the group that ith item belongs to and is equal to -1 if the ith item belongs to no group. Okay, so they're groupless and then with -1s. Okay, the items and the groups are zero indexed. A group can have no items belonging to it. Return a sorted list of items such that the items belonging to the same groups are next to each other. Okay, there are some relations between these items. Before items is a list of containing all the items that should come before it. Okay, return any solutions if there are any more, if there are more than one solution, and return an empty list if there are no solutions. Okay, so it sounds like this is just some sort of topological sort where you're given a sort of like dependencies, if you want to call it that, and then just kind of go through it in some way, and then you have to handle the -1s, I suppose. But I guess for the -1s, you could just give it a arbitrary group, right? So yeah, and then what's group? It's just group to group numbers, and then any constraints. Okay, that's fine. Okay, so let's do that then. Um, okay, let's just do. I mean, I think it's just topological sort. We could chat about it more if you all want, but we'll see. What's n? Is group I always n? Or group length is n? Okay, because it's weird that they give you the n because it's already kind of part of the group size. But I guess maybe for some language it is. So that's what I was looking for. But let's say 4 is times n. So we just set it up, and then now we do for I in range of, I guess, just n. Now we do if group sub I is equal to -1s. Then I guess now I can't do that yet. Hang on. It's always less than m. What is m? M is the number of groups, and m is always less than n. Okay, just want to make sure the constraints. I mean, it's fine if I just have to check for it otherwise. So, cool. So I guess actually we should. Okay, fine. For G and group, group used sub G is equal to true if G is not equal to -1. Okay. So now we could do if group is equal to -1, then we match it to the lowest number. Let's label it slightly better. While group use lowest, and while this is true, then lowest increment, and then now group sub I is equal to lowest. Oh, and then group used lowest is equal to true. Actually, that's just to be safe, because I feel like I may worry about off by once. Should be okay actually. I think there's some like you could use if you want to do mathy fancy term. I think there's some pigeonhole principle or something like that. But yeah, okay. So okay. So now we assign the groups. Let's just print it out first actually. Group. Just want to sanity check. Sometimes it's not always necessary, but it depends on your confidence in certain things. Like maybe I have an infinite loop somewhere by accident. So it takes a while. Okay, so 2, 3. So the 1 should match. And I'm just looking at the example. And the -1s, 2 to 4. Okay, that sounds okay. I mean, as long as they're unique, it doesn't really matter. And now we have to parse the before item for the graph. And then now we could do it in, because, so the reason why I did it that way is now I could now I could phrase the problem in terms of groups. So now it's not just items anymore, it's just groups. Well, n items, I suppose. within the same group. Okay. So I guess before items should be okay for itself, but now we want to do, let's say, group before items. Yeah, I'm using both notations. This is terrible for me. Group before items is equal to, I guess, the number of groups, which is technically, well, now the number of groups, which is maybe lowest. Maybe that's not true, but we could just use n. Actually, no, let's use default dictionary of a list. And now let's go through the before items. How is this? Is this just each item and okay? So now we need index items in before item. Okay. So we just do the lookup on the group, and okay, now we have the group I. So group of index is the group that this item is in, and then now group before items dot append group index. No, is that right? Nope. The other way. Oops. So this append items, kind of, because you want them to be flattened. So okay, for item in items. There's probably a phonic way of doing this. So, so if you're cringing, let me know. I'll try to improve my code a little bit. Python is still, there's a lot of like edgy things that I feel like I'm not super Pythonic yet. But okay, so now this also gives us the group. So let's just put that out before items and then group before items. And then now we should be able to do a topological sort on the first, on the groups, and then within itself. Oh, whoops, right to end. Sometimes I forget. Okay, I mean, obviously, so the groups seems okay. I mean, we could dedupe, but really not a big deal. But I guess this should be a set then. Let's make that a set, and then we can, was it insert or add? I think that's the thing with practice is that it allows you to kind of just be better at, or allows me anyway, to practice language constructs. I could kind of type less as possible, because the less you type, the fewer places you can make a mistake, and then it just also builds your confidence as you go along the way on like certain type of patterns. Okay, but so these are the things that are before. So okay, let's do a topological sort now then. Let's focus on the groups first. What is the output? Okay, so output is just the items. Or is it the reverse items? Return a sorted list that item next to each other. Okay. Oh, so the big initial items number. Okay. Just want to make sure. Okay, so now we do topological sort, which I guess we could do recursively. Yeah, I'll just do it the other way with the queue. So let's say we have a queue. Well, let's just call it group queue. And then we should keep track of the group in degree. Yeah, do I have to invert the graph? So the number of things before, that means that, yeah, we need the reverse graph of these. fine, right? Oh, actually, this is what we want is actually the group of the item. Okay, could have been dangerous, but so now we want to get them by groups. Now we have the stuff that's before, but we don't have the reverse graph because we need the reverse graph to calculate the relaxation. Okay. Well, let's kind of do the reverse then. So now let's do. I should call this group after items. And then now we could actually just instead of editing in place, I'll just copy and paste so I could. Okay, so yeah, okay, that's not so bad. Maybe we also need a regular after items as a result. Probably just inverting the before list, but okay. Just do regular. Also satisfying, I think. And then so the index is okay. So after actually it's here or the item add index. Okay. Okay, I think we're good here. And then now we calculate the in degrees. I guess we should have done it here. Yeah, okay. In degrees. Let's do group in degrees. Oops. Now for, actually, I'm just regular in degrees. In agrees. And then now we could increment. Why did I add a sub underscore? I want item or index? Man, I'm looping my mind a little bit. Item has a. This is they're going the other way, so no, we want the index. And then now we could do the thing where, well, first we do a topological sort on this, and then we just kind of go through it first, item by item for index, and let's just call it group index to be clear. If the in degrees is 0, then we put it in the queue. Yeah, okay. I'm happy with that. And this has like a layer of recursion, so well, not an actual recursion, but just like a one mental recursion, but self-similar structure. But okay, let's do. Let's just keep track of results as well, and then so that we could check if results is not equal to n. That means we failed. Then we return the empty case. Yep. Otherwise, return results. And here, okay. Now we pop the group index. Where's my queue? I guess this is actually a deck. I always forget in Python. The top left. So this is the current group index. So now we want to do what you might call it. We want to relax this number. So okay, let's just, and what that means is you go through its after items, or group in this case for let's say next, but I guess not after in a group index, and then we relax them by subtracting 1. So and also if this is 0, then we could append it to the queue. And that's in theory done for the group. Well, I have to put in the result in theory, but before the relaxation, I guess it doesn't really matter on the order, but now we have to do a topological sort on within the group. Okay, so item queue, let's call it. For I don't have an inverse group mapping, do I? Okay, so group members. So, I guess it's fine. Okay, I guess I'll just do it again for IG. And no, I definitely did not mean this to be an int. It should be a list. Members of G is an I. Okay, so now we have the group members. So for member in group, the group members of current group index. For once, I actually use a variable name that I remember. Okay. Now for each member, we have to put it on the items queue in the same way. So for index in degrees of wait, that's not right. Oh, dot keys. That's why I was thinking it in a weird way. If index is equal to 0, we append it to the index. Okay, and then now we do another while loop for this with while item queue is greater than 0. Current item is equal to item queue dot pop left. And then you relax all the members. So for, I guess just within its group, it's not as necessary to, well, not the way I do it. Maybe there's some weirdness, but that's fine, I think, because I think they both fail it the same way, and that it's either that or we get an infinite loop. But yeah, for after item in after items of current item index. Well, if and this after item, terrible name. What is this group index? It is not wrong that that's what we want to do, but that's not a variable. Oh, this just should be after. Okay. This is mostly maybe done. Whether it's correct is another story. But on pop we should in here current item index. Okay. Whew, that was a lot of typing. Hopefully that's okay. What did I call it? Oh, typo in digress. Oh no. Well, I was hopeful. Okay, I mean, that's fine. Oh, I guess maybe this is the time to try the debugger. Though I think you cannot do it during during a contest, but I hope it's just because I have a typo. Did that work? Or did it just never got whatchamacallit? In degrees. Huh. Is that right? Why does it have in degree of 3? Did I do this wrong? Yeah, I guess so. Oh, silly. It's because we would never populate the stuff with 0 degrees because we only check for keys. That makes sense. Okay. Well, that still seems high. Maybe. But, okay. So this should actually be, I guess, n. But then these things should hopefully trivially happen. Oh, maybe I have to do the other place actually for the items as well. Where do I have it in the relaxation? No, I guess we don't have to. Not anything obvious maybe, but let's debug it again. Almost clicked on submit. Why did they make it the same color? That is so like, I don't know. I think that's my only feedback. Please have different colors. Okay. Group indexes. Okay. So at least it's doing something. Let's do. I'm actually curious how this like technology work. I guess there's just a lot of state keeping on this side. Yeah, I'm impressed, kind of, to be honest. 2, 4. And, let me add another. Was it results? Oops, that's not a. So it's not. So for 2, it should definitely have pop. So by doing something here. Let's start from the beginning. Do I keep my watches? Nope. That's a little sad, actually. Oh, this is the thing where also this is weird. What am I doing here? From this doesn't have any member. So, okay, so there's definitely just a bug. So for each member in it, Yeah, what am I doing? I think I mentally copy and paste and kind of got confused here. Yeah, okay. Well, hopefully it's still better than nothing than before. Well, it definitely should be better than before, but okay. What is items queue? Item queue? What is that? Current group index. So group. Huh. Do I not populate it right? Oh no, it's just it's not empty. It's an array, one element of element 0. Oh, and also this is also not empty. It has one. Okay. Ooh, cannot. I misread this for a second. So let's see. Okay, so that actually went okay. Let's restart. So we have. What is this 6? Did I have it in the wrong order? Like this is the inverse of it? Man, that would be a mess. It's either that or I did the array backwards, which is also fine, maybe. Yeah, because, well, this is also just because the item 0 could be anywhere. Because there's nothing before and it's not after anything, so. Okay, so I guess this is technically right. Okay, now just doing the numbers. 7. Okay, maybe that's right. Is that done? I guess so. They really should tell you more. Okay, so I guess it's just not relaxing the stuff. So let's see how it's relaxing. I think maybe I did the group things wrong. Yeah, I think this is wrong in that my group dependencies are based on each item mapping, and that's not right. I think I had a thought while I was typing it because here is on each item, so not each group by group, which kind of complicates things a little bit. Hmm. I guess in theory I could put it here, but that just feels confusing. Okay, that's because here this is a set, so that's fine. But this does not get deduped. Um, hmm. Oh, that's why I don't get it. Okay. Okay. Yeah, cool. Grumble, grumble, grumble. um, Yeah, this is a tricky problem to get right, but this is seemed to be a heavier programming problem, at least for me, because I think there's like a few silliness. What am I doing? Do we ever relax? Is that right? Did I get the direction wrong? So it never actually relaxes. Where the that's not even the in degree thing. Man, wow. I just have I think I just have confusion all over today. How does this even work? This is not even. Oh, because each item is no, but isn't this a list? Oh, I guess. Oh no, because it's a set, and this is a set subtraction. Wow. I wish it wasn't so. Okay, that is an unfortunate type thing. But okay, but it's still an issue. But it is definitely more correct than before. Uh, but maybe not quite there yet. Hmm. Let's do see in. And then what's tricky problem? It's a potential for silliness. How come I can't see it? Show me. Okay. So, oh, this is empty. Under, I guess that's fine actually in this case because it actually is empty. It's the other ones that have the relaxation. Hmm. Also, they have to fix that so I don't have to click on it every time. But okay, this one's not the empty one, right? No. Does this thing have anything in it? Zero has the group zero. 2 is empty. Did I do the reverse thing? Also, we do relax the 3, but relax the 4, 5. So 3 has 1 in degree, which is 0. But 0 has 1 in degree. No, but 0 doesn't have an in degree. Did I mess up somewhere? Oh, silliness, because I put itself as a dependency, so that's why I never. Okay, so let's fix that. Okay. If this is yeah, if they're not in the same group, and this other stuff. The other thing is kind of okay, though maybe I could keep track of only if they're in the same group that this is the case. Maybe that's the next thing to debug. Okay, is that good? Okay, so it actually does something. Not that much though, apparently. Okay, let's just print the group index. This debugging thing is way slower than I would like because I like to get all the information together. I was just trying to play with it, but and maybe it helps in a way more limited way, but yeah. Okay, so this is the group, so that's 0, and I also need to check if maybe it is used first with. No, no output. Oh, this is. Sorry, friends. And this is why I need to. This isn't even that hard of a problem per se in terms of theory. So I have to get my coding up. Okay, so there are 5 groups, right? 1, 2, 3, 4, 5. So okay, so at least it's doing all that. So now we can focus out more debugging on here. Okay, I think we have to do the group dependency, but this is the case where if the group is you only want to do this dependency on this, otherwise you just may be weird. And also in this case we want to, oh no, I guess that's factor that in. Okay, so this will only contain same group stuff. Oops. Yeah, actually I just print the current group index and also the current result so we know why certain things aren't happening. Put at the end of the loop. Stretching. Oh, okay. We did actually get something and it was right. Oh, okay. I don't know what I changed. Oh, I guess I changed the in-group thing. Okay. I mean, I think this in theory should be good to go because I feel like if anything goes wrong, it will just return the default case. And then maybe I can remove the print statement. Oh. Cool. Let's submit. My fingers crossed. Cool. Okay. Oof. What a tricky problem to implement. Not really. I think I was just being lazy. That took about 40 minutes. Yeah, I mean, I think I was just being silly a bit. Because well, there are a couple of places. One was that I just didn't care about, like, I thought it would be okay if I didn't care about the group. That's one. The other one is I double counted multiple times for items, so that was an issue. And then the other typo was that because I was just using the wrong variable and it didn't trigger off things, even though they have different types because of operator overloading and stuff like that with the set difference, which is a blessing and a curse, I suppose, sometimes. Yeah, overall, it's just a topological sort. It's definitely very tricky to kind of keep track of it, stuff. And figuring out what you need. And it took 40 minutes to implement, even though I knew exactly what I needed to do pretty much from the get-go. So very tricky. I really hope you don't get this on an interview. I mean, at least not this part of an interview, this specific problem. Definitely definitely you'll get topological sort as part of the criteria, but maybe not like this tricky in terms of difficulty to implementation because man, if it takes me 40 minutes to type, it's gonna be tricky on a whiteboard. But also, like if you're just testing for topological sort and thinking, like just one level is good enough. Right? Like you don't really need two levels to kind of think about it. And there's not much disguising to this problem. It's just very straightforward. So it's just all implementation, right? But yeah, and overall, this is all of n in case you're curious, in both space and time, because everything is linear, and also we only process each item once, so it's always gonna be all of n, no matter, even though they could be in different groups and so forth. Um, yeah, overall a fun problem kind of, and this has a big upvote, wow, but tricky to get right, and yeah, I think that's what I have about this one. I mean, I definitely also probably could modularize some of the code to be cleaner. This is 67 lines of code, which is really tight. I mean, really a lot. But I don't even know how much I could DRY. So, like maybe there's some self-similar things with the two Q topological sort, but it's a little tricky. All right, cool.